Hello.
Good noon to one and all. We are here for the session 2, day 5 of this 5-day FDP on waste technology. The expert for this session 2 is Dr. S.K. Sharma, Professor and Head Civil Engineering Department, NITTTR, Chandigarh. Yesterday he had delivered lecture on sewage waste and its management. I, on behalf of Civil Engineering Department, welcome you, sir, to the session 2, day 5 of this 5-day FDP. We are feeling so blessed that we got another chance to hear from you again. So now hereby, I welcome Dr. Sharma to please start with his lecture.
Dr.
Sanjay Sharma sir, please start with your lecture, sir.
आप गेट पे देना 10 मिनट से. Hello. Okay. Thank you. Sorry. I think I got some with the other thing. And now, yesterday, yes, we were discussing about water in general, how to say recycle and reuse water. And this is, and then in that also, I discussed that, okay, our strategy towards controlling pollution was basically when it was at initial stages, we had this dilution technique, and then afterwards this control and then management, and then I think now we are as the problem is growing, so we are more focusing on say waste generation reduction, waste reduction, and in that basically this clean production technologies or say or pollution prevention techniques are very important. So this particular session we will be discussing about what is the basic theory behind this cleaner production, or with some of the case studies also, so that you maybe become more conversant with the this pollution prevention techniques, or you may call the cleaner production techniques. So if we look at the basically this is a technique more relevant to say industrial units or industrial activities, but at the same time, if we are say if we are taking the example of say this cleaner energy or say this water recycling, and even those sort of activities are falling under the ambit of your clean technologies, and that means that wherever we can basically control the reduction and control the waste generation, and wherever we can basically take certain steps towards waste minimization by changing our say either some changing our raw material, changing our some production activities or modification of the equipment, etc. So I think there we can think of so each and every step we basically carry out the audit, and we see that okay, where the how the waste is being generated, why waste is generated, what is the alternative to that particular thing, and then we decide accordingly that okay, we try to reduce the waste, and we try to minimize, or we try to have a zero discharge basically. It may be air, it may be water, it may be solid waste, etc. So if you look into the any say industrial activity, so you see that the activities, major activities include are the raw material extraction. Then after raw material extracted, if some manufacturing is done, it is transported, finally product is used and disposed. And then we have to see here that okay, what are the raw materials inputs and what are the waste outputs. So and this is with respect to your pollution, like most of the things basically which is affecting the our environment and affecting our health, which we discussed yesterday also. So we have to think about that. Okay, that once we go for the say pollution control strategies, so there you must basically ask that what is the cost of pollution treatment. I think it is very high. Even yesterday we discussed that many times plants are not being run. And even I have seen many times going to some say cement plant, etc., or some other things. So they run their control units only when some pollution control person is coming. Otherwise, they don't. Basically, if ASP is there, it is not being working in working condition. If waste water treatment plant is there, it is not in working conditions. So that means that okay, the cost, because cost of running operation cost is very high and construction cost is very high, and the maintenance is almost again sometimes very high. Then if you see that loss of raw material is there, many raw materials basically which are not being used in the manufacturing, so they are getting waste. Loss of intermediates and other products, like as you know that okay, the waste, it may be waste to me, but it may be waste to some other person. So waste is something a thing which is at a wrong place. Then your manufacturing cost, waste collection and handling, and operation of treatment facility. So already we have discussed these things. So these all things, pollution control measures, you see that some money has to be spent on these particular things. And I think this is one that okay, that whatever the local issues are there, so they are basically reflected at the national level also, at the global level also. So basically, if we are causing air pollution sitting at this place, so it affects may not be immediately known to me sitting at this place, but globally, I think we are contributing to that. So global effects are always there. And whenever we are talking about this sustainability and development, etc., and environment also, so there is always a situation where we need to create a balance between environmental factors and the economic factors. Because you have to take into it is not that okay, we stop all the development because we don't want to harm our environment, and then if we are going to say have only economic benefits, completely ignoring the environment also, so at this it is also not a, in the long run it is not going to be a good practice. So basically we need to create a sort of a balance between environmental factors and the economic factors. So there, I think once we talk the cleaner techniques or pollution prevention techniques, there it is very important that we should be clear that okay, that if we are initially, if my investment is high, but in the long run the payback period is also fast. So take the case of these solar panels only. So if you are installing them today, so it maybe initially they may be costing to you, but the payback period is 3 to 4 years. Afterwards, you are net positive. So there, I think you have to convince that whatever the agency is there who is taking these, putting some sort of a this extra money initially, but that money is going to be recovered in future. So that is what I said, that okay, our attitude towards environment is first it was ignoring, because level of our pollutants were too less. Then when some problem started, we started a dilution technique. So mix the water with the fresh water, have a tube well. So put that as extracted water into that wastewater, bring the POD within that permissible limits, and then I think you are not caught by the pollution control people. Then control technique. So pollution control methods, and then we started off thinking recycling, whatever that could be recycled, and then prevention technique. So don't allow the pollution at all to occur at the initial stage. And then we have to, and with all these factors, we have to say that okay, whatever the development is taking place, that development has to be sustainable development, or it has to be like nowadays they are saying, I think this even United Nations, they have set up a green mission. So under that green mission, so this sustainability has been covered, and whatever basically development activities are taken place, so all these activities should be labeled as the green activities. So that is what, if you are saying that environmental factors and the economic factors, they are pulling each other in a different direction, but at the same time, it is essential that we strive to achieve the same goal. And putting into this thing like your production process, if you see the milk loss in dairies, which process only about 15% of the total milk production, is about 110 millions per year, which is good enough to provide the city of Ahmedabad about 2 kg family of 4 persons for 3 months. Similarly, if all the small pulp and paper industry could reduce their waste water consumption to the best level already achieved by some mills, it could save enough water for the entire city of Ahmedabad at 120 liters per capita per day. The annual wastage of chromium salt from all the tanneries equals about 140 crores, and which is a quite huge amount. I think if we are able to save, reuse or save, or we do something about this thing, so we can basically save a lot of money also. So we have to basically meet the sustainable goals. As I said that, okay, that's millennium, as UNDP, they have said that, okay, this is the green millennium to achieve the sustainable development. And by simple definition of sustainability is that the development which meets the needs of the present without compromising the ability of future generations to meet their our own needs. So under this pollution control, this cleaner production, the other terminologies being used are the pollution prevention techniques, waste minimization techniques, cleaner production, resource conservation, efficiency improvement, and green productivity. So these are the basically terms which can be utilized for cleaner production. I think one lecture you already had on waste minimization from Dr. S. C. Jain, where he has discussed, like he must have discussed some case studies and related to that. So in this particular clean productions, actually our focus is that waste is not a waste, but it is a resource, but at a wrong place. So this cleaner production or pollution prevention is a new and creative way of thinking about products and processes that make them. It is achieved by the continuous application of strategies to minimize the generation of wastes and emissions. It is again a continuous process. You may achieve, say, 20% today, next year 30% efficiency, next year 50% next year, and then a stage may come where you are basically controlling almost 100% your waste generation. So if you look into the cleaner production, so cleaner production means you can take it as a economic tool also, because it has got the economic benefits also. It can be taken as an environmental tool also, because it is minimizing the our ill effect on the environment. This thing, it is a management tool also, because you are managing the resources and all that also, and then quality improvement tool also. So all these factors are basically combined together in your cleaner production, application of cleaner production in any sort of a developmental activity. So why we should adopt this clean production for is the because you want to cut the cost reduction is there. You want to control the pollution. You want to conserve your valuable chemicals and other auxiliaries being used in your processes. You want water conservation. Then if you are going to market your basically in the international market, you are going to compete there also. You are this cleaner production is going to help. Like one example, I think I can give is that, okay, I was organizing one, say, visit to UK universities, and then they were evaluating this thing. So we had got this ISO 9000 certification. So once they saw it is ISO 9000 certified institute, so we got the permission, say, way back in say 1998 around, we got those permissions, and basically we could manage in a very shorter time also that particular. So basically, if you are having that certification, your value goes up. better working conditions being created, because better environment, better working environment is there, better environment is there, improved image, same thing, and new market opportunities are created through this sort of a system. Then if you are opening this skill production, your profit margins go up, you get good quality product, you get easier EOP treatment also, reduced your operation cost also, better shop floor environment, and better image in the society. Mineral production will lower the cost of reduction, end of pipe treatment. You will spend less on the healthcare, and then you will spend less on cleaning up the environment. It is a very simple technique if you are comparing, like nowadays this corona. So there, if you are taking a preventive step, there is no need to having sort of a you're taking proper precautions, having mask and sanitizing your place and washing your hands, etc. So that is a preventive step. You're taking that preventive step. Ultimately, if you are not going to get the get affected by the COVID, that means your health system is being being saved and all that. So basically, it is a preventive step. Basically, that is what is there in the system. So that is the basically motive that civilization of Earth, human activities, especially the quest to improve the quality of life by producing more and more products, has already affected the environment, and that is there that we need to create a balance between our environment and the economic activities. So here, if you go any say process, so there is something is being put as is being is an input. Then in the industry, some processing is taking place. You are getting a product B plus C. There B is a useful product, C is a wasteful product. So our focus here is how to reduce this C. So looking at the industrial process, it is necessary to understand that any process activity is neither 100% efficient. Something is always close to the environment and cannot be converted into the useful product. This something is waste or pollution that becomes a liability of the industry. This is often termed as opportunity lost to produce. The percentage of this waste generation is very high, and surprisingly, very few industries realize it. So cost optimization in the process is the only productivity oriented and often overlooks waste generation potential of the process. Here we have to think of this thing, how we can control this waste. And environmental management has always been considered as a dead investment with no expected returns in terms of money or the market aspects. The major reason behind this was the concept of end-of-pipe treatment, which considered the industrial process a black box and looked at waste alone after it is generated. So end-of-pipes, basically, we are not missing it because our environment pollution or pollution controls boards are saying that your specified limits are this. So you will not be allowed to operate your industry. So you will have to bring it that. So basically, but that particular operation maintenance of these treatment technologies has nothing to do with your economic benefits. So there, the interest of the industrialist and the interest of your regulators, they clash with each other, and because of clashing of interest, if measures are taken, so they are never successful. So here, I think unless we convince our industries or our these particular people that this has got some economic benefits also, so only then they will take the necessary step. So this notion often lead to weak implementation of environmental regulations due to lack of conviction among the implementing authorities. And during the United Nations Conference on Environment Development in 1992 held in Rio de Janeiro, shift in the development process which harmony to environment was employed. That is what I think afterwards you have got so many conventions. This in the last Paris Convention, people said, carbon dioxide targets has already been fixed. So many developed countries are not agreeing to that also, including USA, and they said, we are not able to, we are not causing any, no environment say, damage as compared to the developing countries. And whereas the need of the developing countries is that they have to basically come into the category of developed countries. They have to use those technologies. Sometimes technologies are obsoleted. There you don't get any sort of more pollution is generated, and the technology available with the developed countries is coming at a very high cost. So there all these interest and all these things are clashing with each other. So as per this various international requirement, or as per the Agenda 21 of United Nations, it gives higher priority to introduction of cleaner production methods and preventive and recycling technologies in order to achieve the sustainable development. So coming to again, what is the cleaner production? It in general terms describes a preventive approach and is a win-win strategy. It protects the environmental degradation, consumer interest, health and safety of workers, and improves efficiency, profitability, and competitiveness of the industry. So cleaner production is defined as a continuous application of an integrated preventive environmental strategy applied to process products and services to increase overall efficiency and reduce risks to human and the environment. For product development and design, this CP involves the reduction of negative impacts throughout the life cycle of a product, from raw material extraction to ultimate disposal. So each and every step has to be audited and checked that okay, what sort of a raw material is being utilized, then in the manufacturing, in the processing, what sort of a technology is being utilized. Say heating. If you are using say coal for your heating, what is the alternative to do? Because coal, if you are including, so if you are having that instead of a coal, can you go for this microwave heating where your clean energy can be utilized? So that way basically you have to think of your various practices. For production process, cleaner production involves the conservation of raw material, energy, elimination of toxic materials, and reduction in the quantities and toxicity of waste and emissions. For service industries, this involves the incorporation of environmental considerations into design and delivery of the services. So if you want to differentiate between cleaner production and pollution control, so cleaner production offers an alternative to conventional end-of-pipe strategies practiced by industries, while the aim of end-of-pipe approach is to control and treat the waste and emissions when they are already created, whereas CP aims to prevent waste and emission to be generated in the first place. This reduces the need to install and operate often expensive end-of-pipe control facilities like wastewater treatment plants and gaseous emissions. This CP offers a big benefit. So this CP offers a twin benefit of improving economic performance of a company and simultaneously reduces the environmental impact. If you compare this, this is the in this side is the investment, this side is the performance. This is the cleaner production. This is the end of pipe technology. So investment is low, end of pipe, and performance is better in terms of if you are adopting the cleaner production techniques in any type of a system. So key difference between pollution control and cleaner production is one of timing. So pollution is an after event, reaction and treatment approach, whereas cleaner production reflects a proactive, anticipatory and preventive philosophy. So, and there is no doubt prevention is always better than the cure. So here in this case, prevention is better than the treatment. So this does not mean that end-of-pipe technologies will never be required, because your efficiency may not be brought to your 100% something. But by using a cleaner production philosophy to tackle pollution and waste problems, the dependence on your end of pipe solutions may be reduced, or in some cases may be eliminated altogether. Like I was just looking into this thing, the Japanese, they are trying to invent a washing machine which doesn't use the water at all. So they are, because in your washing machine, this soap, it requires sort of a OHN generation. So and that is the basically cleansing product. So instead of using that soap, basically they have basically come out with sort of a scrubbers which are producing this OH, and without utilizing the water, you can clean your clothes. So that waterless, basically this washing machines, etc. So that way, basically, you have to think in terms of improvement of your technology and all that in terms of this. So this cleaner production can be and has already been applied to raw material extraction, manufacturing, agriculture, fisheries, transportation, tourism, hospitals, energy generation, and information systems. Many of the areas in this thing, this cleaner production technique is being practiced. And this is basically reflecting our changing attitudes also. It is important to stress that cleaner production is about attitudinal as well as technological changes. So our first, we should be, our mindset should be clear that, okay, we don't want to create pollution, and this cleaner production, environmentally it is beneficial and economically it is beneficial to us. In many cases, the most significant CP benefits can be gained through lateral thinking without adopting technological solutions also. It may happen that, okay, you may not need to change anything also. I think waste minimization, you must have, whether Dr. Jain has given this example or not, but the example of this one, this fast food chain in Delhi. So they were manufacturing ice cream basically, and the water from their ice cream plant was basically having very high BOD, and pollution control people gave them a notice, either you stop it or do something. So then I think one of the solutions that was just sent to them, okay, that you put the water and some this thing also clean and make a soft drink out of that, and serve as a welcome drink. So they started that. So when that if the BOD was about in the very high, so ultimately the BOD was brought within the limits without going for this thing. So first they served served this drink as a welcome drink. Afterward they started charging for that drink also. So that way, basically, you can say without spending anything, they were able to control their water pollution. So that is what once we talk the changing attitude. So change in attitude on the part of the company directors, managers, or employees is crucial to getting the most from the cleaner production. So basically, we have to think that this is a new and creative approach to enable the production process less waste intensive and is based on different techniques. These techniques can be classified into various categories. Like you can say, first is the source reduction, second is the recycling, and then product modification. In the source reduction, simple good housekeeping or process change may lead to your better sort of a pollution control. And in the process changes, you may think of changing your input material, having a better control process, equipment modification, and technology changes, etc. Even one of the, say, electroplating industries who are manufacturing these tools for their जो plug पाना जो कहते हैं ना, and etc. So they were being manufactured. So they were generating using this for electroplating. They were using chromium, nickel, and all that. And pollution control gave them sort of a notice that, okay, you cannot your pollution levels are beyond permissible limits. Then they were suggested to completely change your technology. So you don't go for this electroplating by chromium nickel, this thing only zinc plating, but go for this laser technique. So there they needed to have this equipment, new equipments and technology, complete technology changes were to be installed. So they made a sort of a plan. It was industry in somewhere in Ludhiana. So they made a change of one sort of plan, and basically then financially, basically it was worked out in if they are right now, if they what expenses they are occurring on this pollution control, and what is the expenses for modification, and then what will the payback period. So payback period came about 5 to 6 years, and then basically they were completely got mentally free from any as a sort of a threat from the National Green Tribunal, etc., NGT, etc. So that is where basically you can think of this thing, like all these things can be this thing. Then coming to recycling, on-site recovery and reuse, and then creation of the useful byproduct from the waste material also. I think many cases are there where we have utilized this, even this fly ash in our from the plants that is being utilized in the cement manufacturing also. Nowadays we are having this geopolymer concrete where I think we are not using cement as a binding material. We are using some other chemicals with the fly ash as a binding material, and it is, you can develop concrete without cement as high as strength of say up to M100 also. And it has got basically performance wise, durability wise, that particular concrete is much better as compared to your cement made concrete. So basically the alternatives, we have to see that, okay, that is what we are, this is the alternative, and we are using the recycling, change of raw material, and with example of change of raw material, and also change of your this also. Even so then good housekeeping is very good. I think maintenance is always important. So basically we in the cleaner production, we must look into to prevent leakages, spillages through preventive maintenance schedules and routine equipment inspections. Improvements to work practice and proper maintenance can produce significant benefits, and these options are typically low cost options. I think a very simple thing is that, okay, if you are oiling is to be done, your own vehicle also, basically that there is a maintenance schedule. You have to change the filter oil after say so many kilometers. You have to change the your like gear oil after so many kilometers. So basically all preventive schedules are being maintained, and this thing done, so the efficiency of the plant will be this thing. So those things also be good host processing will be also fine. Then process change, coming to this is that, and under the process change, the things to be followed is the input material change. This is the substitution of input materials by eco-friendly, non-toxic or less toxic than the existing and renewable material, preferably having longer service life. Like Tenry, if we are using chromium, can we use less amount of chromium, or we can, and I have given the example of this electroplating by chromium, we go for this thing. So think of sort of a this thing. Many times, if waste from a one industry, this caustic soda, and this is where there is the lime soda, your paper and pulp is the one particular thing, which is which was basically is a source of raw material for some other industries, and you can think of basically having that either using some recyclable material, or using the, if it is a very toxic material, what is the alternative of that toxic material to be used in the manufacturing. Better process control. So modification of the working procedures, machine operating instructions, process control parameters, record keeping in order to run the processes at a higher efficiency and with lower waste generation and emissions are to be followed. In case of equipment modifications, yeah, sometimes same equipment requires modification, or sometimes you are no, so whatever the modifications can be done in the existing this thing, like your these smart meters are there nowadays, electricity running this thing, and they say okay, they are and that way basically you are think of even we are in the water supply system, we are going for this this SCADA based sort of techniques, where we are using the techniques to control the flow of the water. Then we are monitoring the things, okay, how much water is being utilized, whether some wastage is there or whether it is in the excess. So basically all the parameters are being seen in your computer screen with the help of this sort of a system, and you are getting a better utilization of your water and less wastage. You are basically finding like some leakages there, okay, you will be able to see that, okay, this particular section of the pipeline is giving the more leakage, sitting at your office only. So, and then you can take the remedial process also. So then technology change and replacement of the technology processing sequences, synthesis pathways in order to minimize waste and emission generation during one of the textile units earlier. So they were this using this heating by this boiler system were having, and they were using the heating system through this by burning this rice husk waste and all that also. So they were given the option of using this I think using microwave heating. So microwave heating initial cost was high, but ultimately that reduced their production cost also, and they came up with the sort of cheaper cloth, and ultimately all other units have to follow basically because they were not able to compete their old technologies. So basically that way, and similarly again like your okay, that example I will. Then so basically the source reduction we have to see that okay, and this thing, so that can be done by the process efficiency improvements. So a method of doing more with less by designing new system or modifying existing ones, and most effective means of conserving materials and sources, like high volume, low pressure spray guns for painting operations, centralized fluid distribution systems, water flow restrictions, energy saving, and light fixtures, etc. can be one of the a few examples of having the improving the process through efficiency improvements. So material substitution, so you replace hazardous chemical with less toxic alternatives, using water-based paints instead of solvent-based paints, replacing solvents detergents with the aqueous cleaning systems. So similarly, if you are going to have a preventive maintenance, which includes any activity that might prevent equipment malfunction and environmental releases. So routine inspections, equipment and storage containers, fixing problems immediately and following standard operating procedures. Then improved housekeeping. So we already discussed that okay, keeping your things clean and cleaning the spills and oils, etc. is the one. In process recycling is considered source reduction if the materials are removed from the process or if the materials are redirected back into the process. Like your in cement plants, ASPs are installed. So whatever the final material is retained, either it is being utilized as a waste for your this thing, or otherwise it is whatever the material is regained, it is put back into your cement processing again. So basically that is what you consume. Similarly, and then counter current energizing in electroplating process, water recirculation, multi-pass coolant system, etc. are the few examples. And one of the basically in the textile unit which we worked is that okay, the waste color waste, like they were using the color this green, red, black, yellow, and blue for different colors of the clothes. So basically what we found is red can be again reused to produce the black this thing. So again similarly other type of colors were again, so 4 or 5 times they can be reused. So basically that then our that particular scholar worked on basically how much water is being saved and all that, and this particular reusing of the recycling of that waste stream of different colors was utilized in that particular textile unit where he worked and provided and reduced the water usage in the by about 50%, at the same time reducing the water load, this waste load many times, because color is very, yesterday we discussed, the color is very sort of a difficult thing to remove. That is what recycling. So on-site recovery or reuse of waste materials in the same process for another useful application within the same company. So example already we have discussed. So production of useful byproduct, modification of the waste generation process in order to transfer the wasted material into a material that can be reused or recycled for another application within or outside the company. Then production modification of the new product design. So changing product design can result in benefits throughout the life cycles of the product, including reduced use of hazardous substances, reduced waste disposal, reduced energy consumption, and more efficient production process. So new production design is a long-term strategy and may require new production equipment and marketing efforts, but payback and ultimately be very much rewarding. So that is what you have seen that if we are going for this thing, so we need to convince ourselves why we want to invest in cleaner production. So investing in cleaner production to prevent pollution and reduce resource consumption is more cost effective than continuing to rely on increasingly expensive end of pipe solutions. When CP and PC options are carefully evaluated and compared, the CP options you will find are always more cost effective overall. The solution investment for CP options and for installing PC technologies may be similar, but the ongoing cost of PC will generally be greater than the control cost. Further, the CP option will generate saving through reduced cost for raw materials, energy, waste treatment, and regulatory compliance, etc. So, the reasons to invest in cleaner production is to have the improvement to product and processes, savings on raw materials and energy, thus reducing production cost, increased competitiveness through the use of new and improved technologies, reduced concerns over environment legislation. We have already discussed the examples by giving this thing. BOD once is covered within your limit, so आपको जो है NGT का कोई चिंता नहीं है कि whatever they may say. So reduce liability associated with treatment, storage, and disposal of hazardous waste, improved health, safety, and morale of the employees, then improved company image, reduced cost for end-of-pipe technologies. So when the cleaner production can be practiced, so it is often claimed that cleaner production techniques do not yet exist, or that if they do, they are already patented and can be obtained only through expensive licenses. It is not true. I think the example of this fast food chain making ice cream is very well applies here. So neither statement is true, nor this beliefs wrongly associates cleaner production with the clean technologies. The cleaner productions depends only partially on new or alternative technologies. ठीक है, अगर आपको नई alternate technologies नहीं मिलनी, तो in between also you may think, okay, that is how to change, how to basically do it. It can be achieved through improved management techniques, different work practices, and many for the self-dependence. So this is one case study of this thing, pollution prevention in medium-sized potato chips manufacturing factory. So it processes 1,500 kilogram per hour of natural raw potatoes to produce 350 kilogram per hour of your chips, and employs 15 permanent experts plus 40 temporary employees when needed. So cleaner production is much about attitude, approaches, and technology management. So this can be illustrated by this thing. So cleaner production medium-sized this thing, water conservation and waste. इसमें तीन चीजें कहेगी. Pollution prevention क्या step होने चाहिए? Water conservation and waste reduction in the dairy this thing, and illustrated from the poultry sector. So this is what you are that in the internal section. Basically, as I said, you have to carry out auditing of the different processes. So here it was seen that how the washing, how much water is being used in washing, then peeling and pulp, what is being utilized, hot water soaking was there, slicing was there, it was generating wastewater, because peeling is generating, washing is facing wastewater, then this heating, cooking was started, and basically that was utilizing and some oil, etc., which was waste was to the order of 1,200 liters per day, and the air emissions were also there. And finally, this is the basically original process used in this thing. So in the so actions to be addressed were in the productivity process. There was a high consumption of water and generation of wastewater that could be reduced. First, यहाँ पे washing में हो रहा था. On the other hand, some waste products such as oil and starch could be recovered, be sold to the other industry, because the starch is basically a raw material for some other industries which can be utilized. Moreover, organic compounds were emitted to the atmosphere and thus generating water problems, failing to take advantage of their potential heat power. So जहाँ पे 1200 वो ज़्यादा था, so उसको भी utilize कर सकते हैं. So aspects to be identified were the non-recycling of water during all the productive process, especially during washing stages, implied a higher consumption of it as well as a bigger generation of waste what was being done. The emissions from cooking unit carried organic compounds as they are not treated but directly evacuated to the atmosphere, not only energy. Some products generated during the process such as oils from cooking cooking unit and starch were managed as waste products instead of taking advantage of this potential use in the other industries. So solutions were introduction. So basically, the actions taken were recycling of water from soaking and slicing process after a previous treatment of their wastewater. Previous treatment, recovery of starch from cooking and slicing stages to be sold to the textile industries. The environmental benefits obtained by clean production measures undertaken in the manufacturing process as referring to water, a considerable decrease of consumption as well as reduction in the pollution load and volume of the wastewater generated because that water was recycled. So lesser fresh water required and more of and lesser load on the your plant also. So reduction of the energy consumption was achieved by the reclamation of heat from the incineration process. And finally, it must be pointed out that the better management of waste products has been carried out, thus implying not only environmental benefits but also economic benefits for the company.
Hello.
So hello. So action taken: recycling of water from washing and peeling stages by means of installation of a treatment unit consisting of a filter, recovery of oil used to the cooking unit and sell to the soap companies, replacement of
Excuse me, sir.
Yeah.
सर जैसे हम यहाँ पे आप पॉइंट क्लियर कर रहे हो कि हमें रिसाइकल करना चाहिए और स्टार्च को जो हम एक्सट्रैक्ट करेंगे फ्रॉम वेस्ट वाटर, ओके, क्या जो उसकी एक्सट्रैक्शन हो, क्या वो उसकी जो कॉस्ट है वो उससे मतलब जो हमारे पास एक्सट्रैक्ट आएगा, एक्सट्रैक्टेड स्टार्च होगा, उसकी कॉस्ट और जो उसको सिंथेसिस करने में जो हमारी प्रोसेस में जो हमारा अमाउंट लगेगा वो सफिशिएंट होगा? क्या हमारे बिजनेस पॉइंट से ये बेनिफिशियल होगा हमारे लिए?
Yes, जो peeling से starch आ रहा है ना, basically peeling का starch आ रहा है. This is basically being utilized by the textile industry. They need it for their purposes, for the clothing mills, वो strengthen करने के लिए. So they are taking it as such for their this thing.
Okay, it is useful.
It is useful. Yes, yes. That is what basically this by one example I is trying to explain is that we must like this particular case study. So we must identify each what is the steps being taken. And under that steps, first step is the wastewater generation. So wastewater is being like flooring के लिए, washing के लिए, उसके लिए जो water generate हो रहा है, क्या हम उसको वहीं पे reuse करके कहीं दोबारा use कर सकते हैं?
So actually the cost of regeneration or reuse is more than for the point of business.
No, it is not. No, same. Yes. No, that you have to basically, it is not necessary that your water reuse is always something that if your cost of treatment of that wastewater is there, if you are reducing your load on the plant, so that also you take into consideration that okay, once you are reusing the water for your own this thing, one your industry is getting benefited because from the environmental pollution proof, your water say raw water cost is being saved, and then you are utilizing that putting lesser load on your raw water. You have to basically calculate totality that okay, what is the this thing, and in the long run you will find that this particular thing is much cheaper. And then as compared to if you have to put some sort of a at the same your internal unit, if you have to put some sort of treatment for that purpose also, maybe sedimentation tank, if it is containing some say this thing, so put that one tank sedimentation tank and then recycle that particular water if it was containing, because washing processing the same water can be utilized. So that way you have to think basically. So think from that point of view that okay, whatever the at whatever stage for each and every unit operation, you see that okay, what my action is, from that action how much waste reduction can be done. Maybe 20% initial, next year you can improve it to 30%. So that is what it is, a continuous process. So you keep on improving your this thing. This management systems are there. So management system means you are improving your system day by day. So that is what basically happening. And this starch, which is otherwise waste, difficult to throw. So it is a product, raw product for the this textile unit. So they are selling that particular thing to them at these things. Like your this fly ash for the thermal plants, it is a waste. But for this cement manufacturing units or for other this thing, I think they are now. Earlier this fly ash was available at without any cost. But if you go to any thermal plant, you want to say, they may say okay, we will charge you They may not give you free of cost, because the total utilization of the generation and fly ash is whatever is being utilized in the cement industry is much higher. So you are not. So that is what basically the this recovery and recycling is the meaning here also. So coming to next point, recovery of the oil used in the cooking unit, and they were basically sold to the soap companies, which were again they were be able to utilize for their purposes. Then replacement of the fuel oil by the LPG, and then recovery of the heat from the incinerator by treating the air emissions generated in the cooking unit. So whatever the heat was being circulated, instead of throwing into the atmosphere, that is recirculated again back, so that to the cooking unit, so that your energy requirement goes down. If initially you are heating, say at a say 800 degrees centigrade, so with this fuel required to heat 800 degrees, but when we are recirculating the hot air, you may not you require only say up to 600 degrees centigrade. So that way basically you are saving the sort of a energy also in this thing. So this is what waste generation, wastewater from washing. The treatment unit, small treatment unit is basically this thing here placed there. Maybe sedimentation tank was placed, and it is recirculated back for washing. Yeah. So it reduces your then which was being used for this potato. So this quantity of water required was saved here. Then this peeling and soaking, etc. So here also you needed this wastewater in the unit 3. This starch that was basically reprocessed, and basically it is sent to the textile industry. And here also the waste oil, again soap industry, and finally heat recovery from cooking area. So it is air emission. This is again that heat recovery is being done, just recirculating that heat through the pipes and all also, and giving again giving to the cooking unit also. So basically in that way they were able to solve a lot of this thing. So results are reduction of water consumption, reduction of wastewater generation, saving up to 2 meter cube per hour or 18 meter cube per day. Cost of water usage, 1 meter cube per day is amount to about rupees 1,44,000. Cost of filters which were installed is about 2,44,000. So payback was worked out less than 2 years here. So this is just an example basically that that whatever you are using. So if you do that. Similarly, water conservation and weight reduction at a dairy plant. So this is an example which describes the cleaner production technique of a dairy involved in this thing. In addition to pasteurized milk, the dairy products, cheese, butter, etc. were there. Products are sold in the regional market. The process approximately 130,000 liters of milk per day. The surplus mix and milk that fails bacterial count is processed to manufacture the other thing. And this is the reason for action and environment issues addressed were the milk delivery trucks, and where the trucks are washed once per day with a combination of hot and cold water. The identification of the problem areas, process equipments, storage tanks, and process and delivery areas are to be washed once per shift with hot and cold water. All cleaning operations were performed using often ended rubber hoses pipe. Operators use fingers at the discharge end of the hose to develop a spray for the cleaning. Spray created manually was relatively insufficient for effective cleaning. Because of the hoses, they were not equipped with shut-off nozzles. Water was often left running for periods of time until the operators had time to shut off the needle valves located on the walls. So here also the action taken were cleaner production were initiated during the waste minimization project. Methods for reducing water use were investigated and implemented. High pressure washers were connected directly to the water supply lines, were purchased for cleaning of trucks, production areas, and equipment. Open-ended rubber hose pipes were equipped with the shut-off spray nozzles. Okay? So as a result of this simple thing, guys, the consumption of water was reduced by 30,000 meter cube per year, and as a result of the project, consumption of water, and wastewater discharges were reduced by the same amount. The cost of equipment was about 3 lakhs, and then the yearly saving was about rupees 4,500. And the cost of the equipment was again this thing, and you can say this with 45,000, 30,000, the payback period was even less than 1 year. So this is simple measures where I think we are only discussing those measures here in which we know you need not have a very high-end technology basically to adopt the clean production technologies we were thinking. Whereas simple steps can be proved very effective. So then illustration from foundry section is, this is one of the couple of furnaces which was in which I think energy was being used, and basically about 80% of unit capacity have less than 3 tons per hour of the molten metal and this thing. So here also, if you go into this thing, so this is the characteristic of the copula, which was being particulate load emission, sulfur dioxide emission, flue gas emission, temperature, and particular size distribution was this one. So, and Supreme Court ordered, this was the case of your Agra and all that. So, Supreme Court ordered about 200 copulas to be closed, and then immediately there were some need to take control of this thing. So these were the standards given by the pollution control boards. So in this, the processes identified, I think that is what basically whenever you are trying to see the apply the cleaner production technique in any sort of a unit, is that okay, you first carry audit, basically. So like audit of melting of the charged materials, molding and core making techniques, sand preparation in that this thing, then metal pouring and machining. I think many of you. Okay. So pig iron and the cast iron is done with the help of a hard coke. About 1/3 of the heat supplied by coke is available in the molten metal. Then on an average, metal coke ratio had been found to be 5:1. In order to reduce pollution load and to reduce fuel consumption, an in-depth study was carried out. And with modification in air distribution system and improved metallurgical process, this ratio has been enhanced from 5:1 to 9:1, resulting in the saving of about 2.5 tons of coke per heat of the 8 hours durations. This was a very good achievement. So that is what the various techniques were identified. Like they said that control measures divided cold blast cupula. So in the conventional cupula, air is fed through one row of this thing system at the height about 2 feet to 2 feet from the base. In the modified cupula system, air is fed through 2 rows of the system, tubes and prior sensing, and then basically what happens, this because of effect of this simple technique, basically instead of having 1 row, you have the 2 rows. So this resulted in higher wrapping temperature of the metal and low coke consumption. Control measures, effective height of the system was basically from conventional 12 feet to 14 feet, which was modified and increased to 17 feet. Effect was better utilization of available heat in the molten metal because of the more volume and more this thing. So this thing. So then limiting the amount of air. In this convention, no arrangement of measuring the volume and pressure of the air blast and generally air supply use is in excess. So कोई control नहीं था, कितना आपको use कर लिया, ठीक है, आपने एक hit and trial system से कर दिया. Here, the provision of instruments was given to control the blast volume and the pressure. So effect was higher tapping temperature of metal and reduction of the coke consumption was achieved. So mechanical charging, manual and hand charging, whereas in the modified system, provision of mechanical charging system and charging bucket was effective. So it also resulted in saving labor, reducing material handling accidents, enhanced life of refractory, and reduced particulate emission due to less erosion of the refractory bricks. Charge opening was again changed. Size of the door opening was 42 to 40 inch to 24 inch. Here the modification door opening was reduced to 30 inch. Effect as less amount of ingress air helps in maintaining the high temperature. Then proper sizing of limestone and a coke. In the conventional use of coke and limestone was in small sizes, and whereas the modified was given the 4 to 8 inch size coke and bigger size limestone was recommended, and effect was the enhanced quality of costing and better combustion efficiency of the coke was achieved. Similarly, miring was done by gas in that particular system, and whereas in this feeding the raw material was done after weighing. So effect was increase in the again. Then the extended height beyond the charging door, basically there was no control in the modified system. Extended height 16 feet beyond charging door was recommended, and this basically affected the integrated additional drought, avoiding chance of backfiring in couple of furnace and conserved heat being emitted in the environment. So lesser amount of heat was being. So basically these steps achieved saving of more than 2 tons of coke costing of rupees 10,000 in each heat for a 3 ton per hour, about 40% saving, make this coke ratio enhanced, which was from 5:1 to 9:1. Particulate emissions were drastically reduced. Life of refractory also got enhanced, and couple of melting capacity also increased. So this modified system has a payback of 4 to 6 months only, and this technology has financially benefited about 400 small units. So these are the few examples basically where you can say that applying this cleaner production techniques without going any costly sort of a things can benefit you a lot. Then I think nowadays a lot of these zero emission techniques and are being propagated and being this thing. So we must, and these techniques are nothing but again the same. Zero emission may not be exactly zero. Nowadays we are talking about zero energy buildings also. Zero energy buildings, it may not okay sometimes, but nowadays actually under of zero energy we are doing net positive energy buildings also. So we are taking all the sort of measures in a particular building, including your architectural design, your construction material, your indoor quality, your energy efficiency, your water efficiency. This all includes, and we are designing a building in such a way that okay, the whatever the energy needs are there, so they are being met from building itself. So that is what your zero emission and all that concept is there nowadays. So that is, I think we have already seen this CP reduction, source reduction is there, recycling is there, recovery and reuse is there, creation of useful byproducts is there, and product modification is there. So it is basically lowers the risk to workers, to community, to consumers of the products, to future generations. And then there are certain myths about cleaner production, that it has a limited potential. It requires sophisticated technology. We have seen, not true. Requires professional, again not true. Requires highly educated and skilled workforce, no, not necessary. Requires higher financial resources, again it is not true here. Requires major shutdowns of the plants, not necessary. Space requirement, again adds to the production cost, not true. Total automation is must, may not be true also. One-time activity, no, it is a continuous process. Good only for companies, very big company, not for smaller companies also doing it. So basically, I think we have to convince ourselves. So what can I do? I am not a scientist. So generally attitude is, who am I? I am only an employee. I do not think I can do much. I have so much to do in the mill. It is not my work. I do not have time. So these concepts are basically are going into this thing. So source reduction is again, I think of this thing: loss of raw material, loss of intermediate products and manufacturing cost, operation cost, then good operation practices. We are already discussed these things. I need not go into this thing. So placing change of input materials has to be adopted. Technology changes, we have already seen that how they are manufactured. Product modification, eco design, etc. has to be interesting. Reuse and recycling has to be considered here. So once we are convinced that okay, this is a very useful methodology, so we must step-wise it has to be implemented. Step 1 is how to start it. Step 2 is analyzing the process steps. Step 3 is generating the so from this analysis create this CP opportunities. Then select the appropriate solutions, then implement those solutions, and then maintain those solutions into a sort of a thing. This is nothing but the same steps have been explained here in this particular slide. So already we have discussed how to get started and how to improve those examples. We have seen that. So going for this summary and all that, you see that cleaner production is a good business sense. It makes good environment sense. It does not increase or require legal capital investment. It forms a sound basis. It has been demonstrated in many parts of the world, including India. It is a voluntary thing. Nobody is forcing you actually. Okay? Like it is your sweet wish that okay you want. You have to. Only thing is okay, and at the same time it gives you mental freeness also, because you are not then basically always thinking about this pollution control, but people okay they will come take sample and all that. If you are not generating waste at all, you are free from any sort of a mental distress also. So the Chinese proverb is composed of two words: danger and opportunity. So, so basically, from the danger, we have to think that, okay, from that danger, some opportunity is always there. So we must look to the opportunity out of any sort of a crisis, and then we think of those things. So current and future trends, basically, that is what I think already we have said, that increasing regulation and government pressures are there. No, this entity is very active, and basically there is a lot of pressure on industries. Basically, there is there. So then increasing cost of waste, energy and materials, life cycle thinking and stakeholder pressures are there. This is the one cleaner production and pollution control technique. It is a cleaner production of continuous improvement. It is a one of solution to a user problem. Process towards use of closed loop or continuous cycle processes, whereas it is a result of a waste materials for disposal. We are focused only this thing, not the total process. Everyone in the community has the role to play. Solutions are developed by the experts, often in isolation. Active anticipation or avoidance of pollution and waste. Here in this case also, it is direct response to pollution and wastewater after they have been created. Elimination of environment problems at the source. Pollutants are controlled by waste treatment equipment and involves new practices, attitudes, and management, whereas relies mainly on the technical improvements of the existing technologies. So this is regarding that adopting the cleaner techniques or pollution prevention techniques in our day-to-day activities. I think it can be adopted by an institute also. It can be adopted by some industry also. It can be adopted any sort of a thing. So where we are, any place where we are generating any source of pollution, it is a step towards waste management and waste minimization, basically. So with that, I think I thank you very much, and maybe we can discuss. So yes, over to Bathinda.
Ji sir, thank you very much, sir. Sir, now we can take the questions from the participants. If someone have any kind of question related to this topic, please unmute your mic and ask the question from Dr. Sanjay Sharma, sir. Any participant, if you have any query? Thanks.
So thank you so very much, sir, for sparing your valuable time and sharing your best knowledge on overview of clean technology for waste minimization. Thank you so much, sir.
Thank you very much. And
thanks to all the participants for patience hearing. Now the time for lunch break. And with this, all the technical session of the 5-day FDP gets completed. For the next session, we will meet at 2:30 p.m. In that session, we will take over live feedback from already selected participants and vote of thanks by coordinator of this FDP and quiz from all the participants. So thanks to all, enjoy your lunch, and we will be back at 2:30 p.m. Thank you.
Thank you. Thank you.
Thank you, sir.